Yeah, welcome everyone, and we'll solve some of the, not some, all of the questions of this daily quiz, which was given to you in corresponding to week 3 of April 25. And there are 4 questions, and they are from the topic of linear algebra under the modern course of engineering mathematics. Okay, so most of these questions, if you had attended the regular classes conducted by me, you should be able to answer these questions without any problem. Okay, so let's get started. Now the first question is, when 2 by 2 matrix is given, capital A, and under the standard basis of linear map T with eigenvalues. See, this whole thing, usually this kind of things are there in some questions. Just to confuse students, they will give you this unnecessary part, but this part is not required to solve this question at all. Okay, what is required is, you have given 2 eigenvalues. You can see they are distinct eigenvalues, and corresponding eigenvectors are 1, 3, and 2, 4. So you can also see that they will be linearly independent because the eigenvalues itself are distinct. Okay, and your objective is to find the value of this expression, which is nothing but composed of matrix element of matrix A, capital A. Okay, so basically you are supposed to find the elements of matrix A. Okay, so 4 unknowns are there. So to solve 4 unknowns, you need at least 4 equations. Okay, and how do you get that is pretty straightforward. We know the property of eigenvalue and eigenvectors, in which nothing but, let's say you have matrix A. If you multiply this matrix with certain eigenvalue, let's say lambda 1, then it is equal to multiplying lambda 1 with its corresponding eigenvector v1. Okay, so this is the standard property or definition, whatever you want to call it. Okay, so this is the standard definition that you use in order to get eigenvalues or eigenvectors, whatever it is. Okay, so we'll use that, and we'll get 2 equations from one eigenvalue and remaining 2 from another eigenvalue. Okay, so let's go and solve this. So let's use this expression, and first multiply by lambda 1 to your matrix A, and similarly lambda 1 to its corresponding eigenvector. Okay, so lambda 1 is nothing but sorry, it's not lambda 1 actually. Yeah, it is A into v1. Yeah, because that doesn't make any sense, because you don't multiply with eigenvalue to the original matrix, you multiply by eigenvectors. Yeah, I was wondering there is something missing here. Yeah, it's not lambda 1 into A1, it is A into v1. Okay, so you post multiply by eigenvectors to given matrix, and then that should be equal to lambda, corresponding lambda into that eigenvector. Okay, so now it makes sense. So let's do this. So you have A, B, C, D as the elements of your matrix A, and first eigenvector is nothing but 1, 3, and first eigenvalue is nothing but 3. Okay, it is given in the question. So basically you are multiplying 3 into the corresponding eigenvector of 1, 3. Okay, so the RHS will be just 3 and 9, because when you multiply any matrix by a scalar, you have to multiply each and every element by that scalar. Okay, and now let's simplify this LHS. So the first element will be A plus 3B, and second will be C plus 3D. Okay, just the standard matrix multiplication. Okay, and now you know the property that if 2 matrices are equal, that is only possible when both or all of the elements of those matrices are same. Okay, so therefore you get 2 equations from this, that is A plus 3B equal to 3 and C plus 3D equal to 9. Okay, so let's call this as equation 1 and this as equation 2. So this is the first half of the solution. Now use the second eigenvalue and second eigenvector. Okay, so in that case A into V2 is lambda 2 V2. Okay, so therefore this AB, CD, second eigenvector is nothing but 2, 4 and eigenvalue is 2. Okay. So it is 2, 4, eigenvalue is 2 and same eigenvector. So RHS will become 4 into 4 and 8. Okay. Now LHS will give you 2A plus 4B and 2C plus 4D equal to 4 and 8. Okay. Now from the matrix equality, okay, all the elements must be equal. Okay. Therefore, you'll have 2A plus 4B equal to 4 and 2C plus 4D equal to 8. Okay. What you can do, you can divide both of these equations by 2. Okay, because that will simplify our calculations. So this will become A plus 2B equal to 2 and the second equation becomes C plus 2D equal to 4. Okay, so let's call this equation 3 and this is equation 4. Okay, so now you have 4 unknowns, 4 equations. Now you can solve. And how do you do that? See, A and B appear in equation 3 and equation 1 only. Okay, and clearly you can see if you subtract 1 from or 1 from 3. Okay, so basically what I'm trying to do, nothing but wherever it is 3B, let's subtract that. Okay, so let's do equation 1 minus equation 3. Okay, if you do that, okay, so 1 is A plus 3B equal to 3 and third equation is A plus 2B equal to 2. Okay. And we are subtracting this third from first, so A gets cancelled. 3 minus 2 is 1, so B is equal to 1. Okay, and if you put this B equal to 1 in any of these equations that you see here, you'll realize that A comes out to be 0. Okay, you can just put it in any equation. Since B is 1, A has to be 0. Okay, so this we got. Now you do the similar thing to second and fourth equation. So it is C plus 2D4 and it is C plus 3D9. Okay, so 2 minus 4 if you do. Okay, so what do you get? Plus 3D9 plus 2D4. Okay, 2D4, and we are subtracting this. So CC gets cancelled. 3 minus 2 is 1, so it is just D. 9 minus 4 is 5. Okay, so D has to be 5. And put D as 5 in any of this equation. If you put it here, it is 3 into 5 equal to 9. So therefore C is 9 minus 15. C is minus 6. Okay, so all of the unknowns you have got now. And then you can write your matrix, that is the unknown part, as. Okay, so given matrix A is nothing but ABCD. A is 0, B is 1, C is minus 6 and D is 5. Okay, so this was your unknown matrix. But this is not what they were asking in the question. In the question, what they were asking is nothing but this expression A plus 2B minus C plus D. Okay, so let's evaluate that. A plus 2B minus C plus D. A is 0, B is 1, C is minus 6 and D is 5. Okay, so this is nothing but 2 plus 6 plus 5, which is 8 plus 5, 13. Okay, so 13 should be the answer. And what is the answer given? Yeah, it is 13. Okay, so it is correct. Okay, so this is the standard way to solve these type of questions where the matrix elements are unknown but eigenvalues and eigenvectors are given. Okay, I think there is one more question in this same category in the same quiz. I think the last one. So we'll deal with that once we go there. Okay. So now let's go to the next question, which is about a given matrix A, which is given again in terms of A, B scalars. Okay, so this A and B are real numbers. And now they are asking you about the nature of eigenvalues of this matrix A. That is first thing. And the second part is, about the diagonalization of this matrices for any value of A and B. Okay. The first thing that you should remember or notice here is nothing but this matrix A is a symmetric matrix, right? Because off diagonal elements are, same. Like if you interchange their ij index. Okay, so it is a symmetric matrix. That also means you can write A as A transpose. Okay, and there is a standard property of symmetric matrices, real symmetric matrices. See, these are real symmetric matrices because A and B are real numbers. Such real symmetric matrices are always diagonalizable. Okay, so clearly you can just eliminate A and D option here because real symmetric matrices, this is a standard property that real symmetric matrices are always diagonalizable. Okay, we have discussed all of these things in our regular classes. If you had attended those, it is a straightforward thing to you. And now only the fight is between B and C option. So now you're supposed to find the eigenvalues, and you can use the property of eigenvalues that the trace is nothing but sum of eigenvalues, and product is nothing but determinant of that matrix A. Okay, so what I'm trying to tell you is, since it's a 2 by 2 matrix, it is easier to do it this way. If it is a 3 by 3 matrix by any chance, then you are supposed to follow the conventional method where you first find the characteristic polynomial for that matrix and then get a cubic polynomial in lambda and then solve it. Okay, but since this is a 2 by 2 matrix, you can get away with using the properties of eigenvalues. Okay, so AB, BA. Okay, one way is to do it conventionally, find the characteristic polynomial and then solve for values of lambda. Another way is, let's say lambda 1 and lambda 2 are eigenvalues of this matrix A. The sum is nothing but trace of matrix A, which is A plus A, which is 2A. And the product of this eigenvalues will be nothing but determinant of this matrix A, which is nothing but A square minus B square. Okay, so now look at the options that they are given. So, you can see, if you look at option C, if you add those eigenvalues, the sum is not 2A, it is 2A plus 2B. Okay, so therefore option C cannot be right. Okay. And therefore option B has to be correct. Okay, you can just check here. Okay, because the sum of two eigenvalues has to be 2A, and that is only possible in option B. Okay, so therefore the correct answer is option B. Okay, so I hope you understood, because if you take lambda 1 as, now somebody can ask, how do you find the actual values of lambda 1 and lambda 2? That may be tricky here. You can do it. It's not like you can't, but it's not that straightforward. Okay, you may have to square the first term, so that will become lambda square plus lambda 2 square plus 2 lambda 1 lambda 2 equal to 4a square. Okay, and from there you can get this lambda 1 minus lambda 2 somehow, if possible. Let me just think about it. Yeah, that will be tricky actually, how to get the exact eigenvalues. But since it's a 2 by 2 matrix, if in either question they are asking you to find the exact eigenvalues, see, in this question you could use these two properties and get the answer. But let's say they have not given you eigenvalues, maybe it's a data entry type of question, so go with the conventional way, because that is the easier one, 2 by 2 matrices, and that is nothing but A minus lambda I equal to 0. So basically you have a 2 by 2 matrix where A minus lambda and A minus lambda are the principal diagonal elements, the rest of them are B. So you just have A minus lambda square minus B square equal to 0. That is nothing but A minus lambda is plus minus B. Okay, because you take B square on the RHS and then take the square root. So from here also you can get the answer pretty quickly. See, this is the condition. So let's take the first case where it is plus B, and second case where it is minus B. Okay. So in this case you will get the first eigenvalue, which will be A minus B, and in this case we will get the second eigenvalue, that will be A plus B. Okay, so this is how you get the exact eigenvalues. For 2 by 2 matrices, things become easy because you can play around with properties of eigenvalues or conventional way also. But in 3 by 3 matrices, I'm again telling you, you have to go conventional way if they have not given you any of the eigenvalue. Okay. In some questions, what they do, they give you a 3 by 3 matrix and one of the eigenvalues is also given, and then you are supposed to find the other eigenvalue, other remaining two eigenvalues. Okay, so this is how you should tackle these questions. Okay, pretty straightforward question. You may get confused in the diagonalization part, but if you had attended the classes, you'll know that it's a standard property. Okay. Yeah, now this is an interesting question. Okay, because they have given you three 2 by 2 matrices, and their some algebraic operations are resulting in matrix M, which is also 2 by 2. And these coefficients, small a, b, c, are the unknowns here, which you are supposed to find and give the sum as the answer. Okay, so there is no option here, so it's a data entry type of question. Nothing to worry. Actually, in this question, more information is given than what is required to solve this problem. Okay, so let's use the given information first. Okay, it is CC. Okay, so now what is M and what is let's write this so that we can get the equations. Okay, so M is -1, 8, -3, 9. Okay, small a is unknown, capital A is 1, 1, 2, 3. Again, all of this information is given in the question. Capital B is -2, 1, 4, 3, and C is 1, 3, -1, 4. Okay, and now multiply and get the equations. Okay, so what I'll do, I'll not write everything. What you can do is get the first element of every matrix. Okay, so here it will be A1 minus 2B plus C, and it should be equal to -1. Okay, so like that you should do to save the time. Okay, so therefore the first equation that you get is A minus 2B plus C. Second equation that you'll get is A plus B plus 3C. And similarly, the rest of the equations will be 2A, 4B minus C. 9 will be equal to 3A, 3B plus 4C. Okay. So now here you have 3 unknowns and 4 equations. So as I told you, here more information is given than what is required. So no need to get any confusion here. Take any three equations and solve. Okay, so let's take first 3 equations and solve. So we'll solve these equations, this system of equation, and the answer will be unique because otherwise the question itself will be null and void. Okay, so this system of equation, any 3 equations will give a unique answer. Now, if you look at first 3 equations, there is no clear pattern here. Sometimes, if you add these 3 and subtract it from the fourth and something like that, you get some answers. But here, nothing like that seems to be happening. No need to worry. What we can do is we can use our linear algebra concept of, this Gauss elimination method to solve the system of linear equation. So if you do that, what it will become is you'll have one coefficient matrix, then the unknowns A, B, C, and then RHS. You will have another the non-homogeneous part. Okay, so it will be 1 minus 2, 1, 1, 1, 3, 1 minus 2, 1, 1, 1, 3 here, and then you'll have 2, 4, minus 1, and on the RHS you have -1, 8, -3. Okay. Okay, so now you have to use that Gauss elimination method because that will give you faster answer rather than just trying to find any pattern or anything. Okay, so if you do subtract 2R1 from R3 and subtract R1 from R2, no, R2, R1. Okay, so then what you get is basically the first row remains as it is. You don't touch it because that's not required. So here also this -1 remain as it is. These 2 elements will become 0. That's the point of doing all these things. So you'll have 1 minus -2, that will be 1 plus 2. So this will be 3. This will be 3 minus 1, 2. Here it will be 8 minus -1. So it will be 9. Okay. And similarly, here it will be 4 minus -4. So that is 8. -1 minus 2 is -3. And -3 minus minus 2, so that is minus 1, if I'm not wrong. Yeah. Okay, so now you can further look into these things, but now it is, the easier part is just get the two equations from the last two rows and solve this. Okay, so that will give you 3b plus 2c equal to 9, and another equation will be 8b minus 3c equal to minus 1. Okay, so what I can do is I can multiply first equation by 8. Okay, so and second equation by 3. So this will become 24b 16c into equal to 72. So I'm just multiplying by 8, and here I'm multiplying by 3. So this will become 24b minus 9c minus 3. Okay, why do I do that? Because now you can see we can subtract these equations and get some answers, right? So what you can do is, the first equation is 24b plus 16c equal to 72. Second equation is 24b minus 9c equal to minus 3. Okay, so subtract the second from first. So 24 goes away. This is 19 plus 6 plus 19. This is 25. This is 75. So this will give you c as 3, and put c as 3 anywhere and you get the value for b. Okay, if you put c as 3, b should be 27 minus 3, 24. So b has to be 1. Okay, so c will be 3 and b will be 1. Okay, now what you can do is put this b and c values in the first equation. Okay, so from here you can get one equation, that is a minus 2b plus c equal to minus 1. Okay, so use this, and a, what is it, a minus 2b plus c minus 2b plus c equal to minus 1. Okay, so use b and c values here. So this will be 2 into 1 plus 3 equal to minus 1. So a turns out to be minus 2. Okay, because RHS is minus 1 already. And then the last part, which is d, but actually d is not required. Okay, because what you need to find here is, if you go back to the question, you're d is not there actually, sorry. You're supposed to find a plus b plus c. Okay, and you got the a plus b, abc values here. So a plus b plus c turns out to be minus 2 plus 1 plus 3. So the answer should be 2. Okay, so it was an interesting question, lengthy question, but you're supposed to use various concepts. See, many of the students will get stuck where you have 4 equations and 3 unknowns. Don't stop. If you don't see any obvious pattern, just take it as a system of equation, any 3 equations, and solve for ABC, and you'll get the answer. Okay, you can repeat the exercise with different values, or different equations. You should get the same answer. Okay, try that if you want. And now let's move on to the next question. I think that is the last question. Again, I told you at the beginning, this last question is similar to the first question that we solved. Okay, so here also they have given you eigenvalues 1 and 4 and corresponding eigenvectors. The original matrix M has to be found out. Okay, so one way to do is to do this is same as that of question 1. Okay, you can refer back and solve this. You'll get the same answer by following the same process. But since we are discussing this, I thought I'll introduce to you this concept of diagonalization of matrices. The reason is, see, here the eigenvalues are distinct. That means the eigenvectors are linearly independent. Okay, and that is the basic or the important necessary condition for diagonalization of the matrix. Okay, so what I'm trying to tell you is, you can write M given matrix as PD P inverse. Okay, this is the concept of diagonalization, and diagonalization of this matrix M given matrix M is possible. Diagonalization of matrix M is possible because of, is possible due to distinct eigenvalues, or due to linearly independent eigenvectors. That should be the correct terminology. Okay, eigenvectors. Okay, so that is, I mean, we have discussed in our regular classes. So if you have, it's a 2 by 2 matrix. So if you have two linearly independent eigenvectors, the diagonalization is possible. Okay, and this P matrix will be nothing but the first eigenvector as the first column and second eigenvector as the second column, and matrix D is nothing but a diagonal matrix with your eigenvalues as the principal diagonal elements. Okay, this is a standard diagonalization process. So V1 and V2 are given in this question, which is 1 minus 1 2 1. Okay, so 1 minus 1 2 1, this will be your P matrix, and eigenvalues are 1 and 4. Okay, so this is how you get. Now to find this matrix M, you also need P inverse, right? If you look at this definition of diagonalization, PD you already know, you need P inverse. Okay, so since you know matrix P, you can calculate P inverse. Okay? That will be 1 by determinant of matrix A, matrix P, and for a 2 by 2 matrix, the inverse is a easier thing to do because of the standard formula where you exchange the principal diagonal elements. Here all of them are 1 1, so it doesn't matter, and you change the sign of diagonal elements. Okay, so 2 will become minus 2 and minus 2 will become plus 1. And what is the determinant of this matrix? It is 1 minus minus 2, so it is plus 3. Okay, so therefore P inverse is 1 by 3, 1 minus 2, 1 1. Okay, now you have everything P D P inverse. Now you just have to do the matrix multiplication. Okay, so this M will be P, which is nothing but 1 minus 1 to 1, and this is 1 0 0 4, and there is 1 by 3 multiply here in P inverse. I'll just take it outside because we have to do the matrix multiplication, and then you have 1 minus 2 1 1, 1 minus 2 1 1. Okay, so start from any end, do any two matrix multiplication, and then do it with the third. So let's multiply the last two. Okay, so if you do that, you'll get 1 as the first element, then minus 2 as the second element. This will be 4. Okay, and this is again 4. Okay, now multiply the remaining two matrices. You will have 1 plus 8, so first element will be 9. This will be minus 2 plus 8, this will be 6. Then minus 1 plus 4, 3. Then 2 plus 4, 6. Okay, and now divide by 3 to each and every element inside it. So you will get 3, 2, 1, 2. Okay, and that should be your answer. So if you go back to the options given, 3, 2, 1, 2, yeah, so option D should be the correct one. Yeah, and option D is the. So the point of doing it this way was, see, I could have just stopped by just telling you that you follow the same process as question 1 and then you can get the answer. But here, you can do it in this diagonalization technique also using that. Okay, and since it's a 2 by 2 matrix, it's easier to do. If it is a 3 by 3 matrix, it will take some time, but I don't think you should go for that. Go for the diagonalization technique in 3 by 3 matrices. Okay, it will become very difficult then. Okay, so I think this is the end of this session, and yeah, so we'll meet next time. Okay, so and then we'll solve some other problems. So till then, bye and see you next time.